This conference will now be recorded.
All right. Thank you very much. Good morning, good afternoon, everyone, wherever you are. I think good morning in India only one time here. I mean, always I think of US, we have three multiple time zones. So good morning. So welcome to the second day session. And I heard we have a lot of good feedback about the first day. And director also called, I believe, Dr. Raju and team, and it was going very well. Congratulations to Dr. Raju and team and entire faculty for making this happen. Thank you very much, for your support. And I saw some press clippings also, very encouraging. Though I don't know English I can read, Telugu I have to ask somebody to read it, but it's very encouraging news. Thank you, Dr. Raju, for sharing. So without further ado, let me start the second day of the sessions. So let me pull out my the first day session, what we have. Now, is there any burning questions in the first day? Means it's really which is you want to ask any. Maybe I can take two questions, then we can proceed. And is there any questions yesterday's session? Anything is not clear? Anything you want me to, or Bharat want me to recap? Anything is not clear? Please, I suggest to chart your question so that I can read out, or moderator Dr. Raju or someone can read out. Yeah. All right. Any questions from any audience? All right. So no questions. Probably you're all getting back after your breakfast. I think we'll get there. Okay. All right. So let me share my day two slides. It's a fresh slides which we created for your this thing. So I can share my screen here. Okay. Okay, so I need to have that share the screen here. Okay, computer audio, then okay. Okay, can you able to see my screen or?
No, sir.
No screen sharing. No screen sharing. Okay.
Yes.
Can you see that, man?
Yeah, it's visible, sir.
Yes, yes, sir.
All right. Okay, good. Thank you. So what I'll do is that I think one instruction I got, Dr. Raju said that we'll keep my phone is on in case if I'm not audible or anything. Dr. Raju, he'll contact me on the phone. You might hear his ring. So because I keep talking, and if in case if you're not able to hear, then I don't know, So don't hesitate, Dr. Raju and team, contact me in case if you are having any problem in listening. All right. So today we are going to talk about. Yesterday we very touched upon the protocols and standards, but we didn't had much in-depth knowledge or in-depth discussions. But we had a very introductions. And then I'm going to walk you through some smart city use cases. What we do as per NIST guidelines. And then we have the programming IoT hardware and sensor, and then we have some demonstrations. So we have the let's go on to the IoT protocols. See, when it comes to the protocols, we have three different set of protocols. One is the hardware, means your hardware means actuators, hardware. Actually, you are connecting the devices to the microcontroller. We talked about yesterday. It's basically you have 3 or 4 different kind of protocols, right? One is the I2C, second one is the UART, and the third one is the SPI, which is, some people call it as GPIO, some they call it as an SPIO. It's a peripheral interference. If it is a digital, purely digital, we call it as a general purpose input output. If it is analog and digital, then you have a serial peripheral interface. Then you can convert them into digital and connect it. And then you have the UART, which is universal asynchronous receive transmitter. And then we have the this I2C, right? So we'll run through. That's one side. For the networking, there are different protocols. Networking is a so big subject. I'm not covering up this. In fact, at the university, we teach one quarter itself on the network. We have one subject, networking technologies and solutions, one subject. So we're not talking about that. And the third one is the cloud. We talk about the cloud protocols. That yesterday there was good discussions. We went through that MQTT. Then you have HTTP, HTTPS protocols, right? So now we have the see, this is that I2C, UART, SPIO, and the GPIO communication protocols. I'm sure many of you are from electrical and electronics background. You have gone through several times, but let me quickly glance that what those protocols are there, what are the different sensors we have. We'll so we have integrated I2C protocols, which is basically introduced by Philips Semiconductor in 1982. Low speed devices, basically, it's 100 kilobits per second to 3.2 megabits per second. In that range, you can select the speed, and it has the master slave communications. When I say master slave communication, there is a clock. That clock will be interfaced with your input signal. So you will synchronize the clock with the signal. When signal comes, you actually enable or disable the output or the input, right? And slave has a unique address. So when I say slave, it is basically sensor devices, right? You have a temperature sensor, humidity sensor, anything. It's called the slave devices. It's actually sometimes very old back. They're using that master slave. Now in US, we wanted to call it as an master and just a device. Because master slave looks like something different, but we wanted to. It's a very conventional way of the master means the clock and slave is the devices. So actually, whatever master says, the slave has to follow. This is some I2C the diagram here. You have clock, as you can see, the master clock, and A to D converter, and digital to analog converter, and then the device. So you could be A to D, it could be D to A converter. The clock will decide when this output goes there. So as you can see here, we have SDA is a serial data line, and then SCL is a serial clock. So I put that dotted mark there, which shows that is the valid data. Means the data and the clock has to be on the same path. You can have positive trigger, or the upper hand trigger, or the negative trigger. Here I used it as a positive trigger. So whenever there is a rising edge or a falling edge, that's the right word, sorry, rising edge or a falling edge. Whenever there's a rising edge, the data is connected. Whenever there's a falling edge, the data is invalid. If you really took into signal generator, a pattern generator, you can see that. Am I paused here, or I can go ahead? Is it been paused here? Is my screen and audio video clear? Of course, audio and screen has to be clear. My video is not that important. Yeah. Dr. Raju, is it clear? Mine. Okay. Okay. So we have this master slave device here, and then so this is some kind of an it isn't. So this is the universal. Next one is the UART, universal asynchronous receiver transmitter. That is UART, which is basically like it used to be like RS-232. Initially, I don't know if any one of you are there. If any senior faculty member, they might have come across that RS-232. At least I have come across RS-232. We used to have a printer and used to have a monitor also, RS-232 in the serial, and it used to take the data one by one. RS-232. It's a very slow printer, but very robust. So transmit bit serially mutually agreed upon this, and then it has 9600 baud, 115200 baud rate, or 10 megabaud. That was the speed those days. Now it can, yeah, and then has a single wire in each direction. This has VCC and ground, and it is asynchronous because there is no clock in the UART. It keeps sending the data from one end to other end, from transmitter to receiver. It keeps sending the data. So typically, this kind of sensor I come across in some of the linear, data you want to send it. Whereas in I2C you have a clock. It's not linear, right? It always matched with the clock. In this case, there is no clock. It keeps sending. One example I can give is air quality. In the city, when you go to any smart city project, air quality, they keep monitoring the air quality, CO2. CO2 is considered as one of this area. So it has got the in each direction asynchronous, as there is no clock involved in that. Then the number of start bits is typically 1 or sometimes 1.5. It's basically you transmit the bit start bit 1 or 1. Normally we use it 1, because 0.5 will become little confusing. Smart city, when you use with the air quality CO2, it is a UART sensor. Like that, anything you want to get in linear output, UART is the best example. And number of data is typically 7 or 8, and it has a parity bit, just to check the correctness of the data. Parity is a checksummer, right? Whenever you send a parity bit along with your data, it checks is a parity bit. And number of stop bit is typically 1 or sometimes 2. So 1.5, 1 to 1.5 is the start bit, 1 or sometimes 2 is the end bit, and 1 is for the parity bit. So remaining is what we have 2. Say 2, 1. Even you take the start bit, 2 plus 3, 1 bit, and it has parity 1 bit. So 2, 3, 4. Remaining 3 to 4 bits are used for the data. You can define the data. So this is some timing diagram. You just see that is a transmit data. It starts at 0 and 1010 it starts, and then it stops, right? It's taking it to 0. And similarly for the transmit, it has got the bit width. We can transmit during that level, positive this rising edge or the falling edge. And then the receive also you can see that when it's transmit, when it is a rising edge, the data is transmitted. When it's a falling edge, the data is received, right? So it's like going back and forth, right? Transmit during this rising edge, and receive it during the falling edge. You can reverse configure also, and this is actually the data what takes place. You can see that start data frame and the stop there. And then the serial peripheral interface, it has got the SPI bus synchronized communication interface specification developed by Motorola. Then these are some specifications of the SPI here. So this is that SPI master and slave individual, and then SPI and slave daisy chain. You can do in SPI daisy chain also, means one transmit you can put that as an input to one chip, and then another chip can be an output. Let's analyze this. So it has got a serial clock, it has the data output, and it has got the data input and general IO. So as you can see on the right hand side, we have the data out, that is SDOX is going it as an SDI into another slave, and then SDIX is coming from SDOX. That means you ask somebody to operate, and then that will be that output of that SPS slave will be an input to another slave, but everything is controlled by the master. There's a clock, what it decide. Clock can decide, hey, now say for example I have this SPI slave, SPI, let me just see, so let me see. So this is I'm just moving my cursor here. So you have the SPI slave, SPI slave, SPI slave, right? So you can take this clock and put that as an input, and this one, the STIX, is coming from an input output of this SPI slave here. You see here. So everything is controlled by this clock. Clock is what it decides. Okay, you send the input from here, and now input from here. It's like a chip select. We are selecting that particular chip to behave like an SPI Lex and this one. All right. So then general purpose input output. This is you will see quite often in Raspberry Pi. You have a GPIO pins, right? You can use those pins. You can configure it input or output. That's the beauty of that board. But everything is decided by the chip enable. We make a 0 for input, 1 for output. So more predefined GPIO pins can be enabled or disabled, may be exposed to the developer for configuring or state setup here. So this is just a block diagram that's shown here. We have an LED, and we have a switch, which basically you can enable or disable. When you enable, the LED glows, and when you disable, the LED off. Okay, so that's about the connections from sensor actuators to the microcontroller. That is one kind of protocols. You have I2C, UART, SPI, and GPIO. Now let's see what is happening on the networking side. Like I mentioned, networking is a so big subject that I have just taken from one quarter syllabus to fit it into this one. So basically, IP address, any circuit to take, it has got any internet protocol connected device, it has got an IP address, right? We call it as an IPv4. It used to be, now IPv6. 32-bit address that uniquely and universally defines the connection of a host or a router to the internet. An IP address is the interface. Basically each your devices has got the IP address. You take any connected devices to the microcontroller. Sorry, from microcontroller to the cloud, we have an IP address, right? So we connect as IP address, and then it used to have a 32-bit. Now IPv6 has made it 128 bits. Yesterday we talked about it, why we changed from 32 to 128 bits. Maybe I'll pause here. Can anyone say a little loud here? I will open up the microphone. One of you, please. Why we changed from 32-bit to 128 bits? Just to make an interactive session. Please, can anyone answer that? Or you can chat. Anybody wants to take a guess? Somebody has to be there, some chat, okay. Why we went to, why it's now 128 bits from 32-bit? To provide higher address space. That's exactly, to increase number of addresses. Yes, exactly, thank you. So that's the this one. So okay. Thank you for that. Now somebody is requesting me to enlarge the screen. Is my screen okay? Is the full screen there? Anybody from organizer, please? Is my screen okay?
Okay, sir.
Okay. Okay, good. So 32-bit and then so IP 32-bit long, all address are unique and universal. So when you have a 32-bit, you can address only so many devices, right? It's I'll just very quickly run through that. I want to go to real demo, because that's where these are all available for even textbooks or but I want to just very quickly go through that. So address space of IPv4, then classless addressing, special block and special addressing in each block, then this is that, whenever you see it on your computer, you'll see that 128.11.3.31. What does it mean? It is nothing but your IPv4 address, so it converts everything into binary and provide that aspects to that, yeah. So then in IPv6, we have proposed in 94 core set of IPv6 by IETF, then it was declared in 2014, and then 32 bits to 128 bits. Basically, if you see the 2 to the power of 128, we can address billions of IP addresses, right? So that I can address all the devices in the universe, at least as of now. It also a hierarchical structure of addressing the space in favor of optimized global routing. So this is some kind of an IPv6 addressing, how we can enforce that addressing. So okay, so that's about the connecting the network. Now what are we doing it on the real connections? We have a Bluetooth enable, 6LoWPAN, then ZigBee, Z-Wave, NFC, LoRa, WAN, and Sigfox. NFC, LoRa, WAN, and Sigfox have become very popular for IoT device, the IoT connected devices, because LoRa, it's a low range, devices. It's becoming very, very popular connected environment there. So Bluetooth technologies invented by Ericsson, and it's basically wireless, right? They found that so many wires are going around, so they said that let's cut down the wires. They cut down the wires and then put the data over the shorter distances, and then the short wavelength and UHF radio waves in ISM band from 2.4 to 2.485, and conceived as a wireless alternative to RS-232. Actually, they want to replace these wires. RS-232 is still a wire, right? They want to replace. That's why they connected this. These are the Bluetooth features, as you can see. Its range is 70 meters. It goes up to external range is 70 meters, but the Bluetooth 4 goes up to 100 meters now. I mean, it's not specified, but I know it's 100 meters, then external 50 meters, and maximum current it draws is 15 milliamps. 15 milliamps is for one connections. Optimize or a coin cell and optimize to a coin cell, and then output power 100 decibel milliwatt, and then we have a connection latency of 3 milliseconds, and it has got the star extended to mesh, and then it has got more than 2 billion devices. It is GFSK, which is a frequency shift keying model. The modulation used as a frequency shift keying, and then 2.4 gigahertz is their bandwidth. Then you have the adaptive frequency hopping. That's a big subject, hopping. When you have the signal, there is those of you are from communication engineering, the hopping very well, how it's generated. And it has got the securely 128 bit of encryption, and sleep current is 1 microamps. Sleep current is nothing but, when you are not connecting any of the devices, it consumes about 1 microamps. Payload is just 727 bytes. I don't think any other communications will have this 27 bytes. 27 is a percent of the overhead, but still I consider it as a less payload. Broadcast connections, even data models reads and the writes. So you can release the time, you can go through the details. For the interest of time, I want to just very quickly run through that. These are all some of the Bluetooth devices you might have come across. That is, Nokia, LiveScan. These are all the old devices, but more and more health devices are coming in the Bluetooth. For example, any of your heart rate monitor or your blood pressure monitor, everything is coming with the Bluetooth devices, and you can connect and then connect it to the device, and from device can upload the data to the cloud. So then you have the 6LoWPAN is an acronym for IPv6. Yes, 6LoWPAN is another public area networking for IPv6, and its interest area from the IETF. Yesterday somebody was asking that what is that IETF, and IETF is a standard body. So it's nothing to do with any of they just approve that standards. And then smaller devices and low. Basically, what they thought is why you need to have such an IPv4 and IPv6 now for connected devices. Why don't we have a low end of a devices? So I mean low bandwidth. That's why the 6 low public area network. It's called 6 low power. Wide area public network. So this is used widely for IoT. And then encapsulation should be able to participate within the IoT. So and then we have the encryption and header. This is as per the IEEE 802.15.4 based networks. So then desired working connection with the local network, metropolitan area network, and wide area networks. So this is basically, as you can see, it's a star topologies. Engineers felt that small devices were being left. That's why they consider this. And each a bridge device can connect the two, like machine to machine. Anything machine to machine you want to do that, this is a very good connection there. For example, you want to do a smart city project, you can do the smart city project, based on the smart city project. One is that smart street light, right? All the LEDs are digital control, right? You can connect through the 6LoWPAN. You can connect one mesh network, connect those LEDs to that mesh network. That mesh network can transmit to the backhaul of your fiber optics, or your any of the IPv6 network. So you don't need IPv6 or the fiber optics network to connect a small LEDs at a smart city. You connect it to one mesh network. It's like always I give this example, like your cable TV, right? If you have a cable TV, what they do, they get from the transmitter, get to some kind of an I don't know what they call it. They used to call it as an hub or something like that. I forgot that word. So connect those from satellite to that hub, and that hub can connect to multiple TV receivers. That's how the cable operator is to work, right? It's something like that. So you don't have to bring the satellite for each connections. You have one decentralized connection, and connect everything from there. You connect it. Now the crowdsourcing is also coming. What the crowdsourcing is, you transmit data from one sensor to other one. That device or a sensor can be a transmitter or a receiver to the next device. It's actually hopping. Multiple sensors you can connect. So that you are not overburdening or consuming a lot of power from the original sensors. Okay. This is the ZigBee, is a wireless protocol that everyday devices use to connect to one another. And then the ZigBee is an IEEE 802.15.4 based specification. Is defined by the ZigBee specification to be simpler and less expensive, and low power with 10 to 100 meters of line of sight, depending on the power output and the environmental characteristics. So these are the some other features of ZigBee. You will come across a lot of ZigBee devices, when you are connecting to an IoT, you are connecting lot of back-end devices to this, and you will see those connections. I think we have some examples. We'll be able to demonstrate that. This is the ZigBee. As you can see that personal healthcare, industrial control, residential light, commercial control, PC and peripheral, consumer, all are connected through this ZigBee. These are some examples. These things can be connected to an IoT cloud. That IoT cloud will act as an hub there. Then near field communications, mobile phones, several mobile application has got the NFC. So used for payment systems, check-in systems, operating frequency. Basically, even your any app you write, you have a barcode there, and you just scan it from this. Just nothing but a near field scan, right? You just scan it and then give it to the phone there. Yeah. These are the specification: data rate 106 to 424 kilobits per second. This is an interesting thing happening. LoRa is a very popular one. So LoRa technology. Anybody has heard of this LoRa? Let me pause here and just check. Anybody has used the LoRa? Nobody has used. Okay, that's fine. Yeah, somebody's used that without long distance. Okay, myself, no, sir. Okay, that's good. So yeah, LoRa is another communication protocol is picking up. It has got the LoRa alliances, low range alliances, and then single base station which connects up to 30 miles away. For example, places like Warangal or surroundings cities, they can use this LoRa antennas and then connect the devices within that range. You need to have a networking, you need to have a transmitter, you need to have a receiver. It's not a software. You need to have some hardware components to enable your LoRa. So consumption extends battery life up to 20 years. Then you have 3 ways infrastructure investment. Actually it reduces. Every time you don't have to go to Reliance or what's that other one, the operators there, Airtel or whatever. So you don't have to go through them, right? You have your own band to communicate within those public area networks within that city. You don't need external, because every time you have to pay for the data or you have to pay for the multimedia files. Yesterday we talked about multimedia files, right? So then it is secured, embedded end-to-end. It's an encryption is AES-128, and LoRa WAN ranges from 0.3 to 50 kbps. I suggest when it comes to normalcy, you can create this LoRa, or even at the residence, only you need to get the components. You can create the LoRa hub within your residence under this COVID-19. That could be another example, right? How we can communicate, how we can help each other from one place to other place, through LoRa. You don't have to depend on that. For example, a small community. Okay, now what help they need, whether we can help them, in their needy places. You can have the grocery list, or you can have any other essential. You can create that one. That is some kind of helping the community. You have a township. You can create a LoRa network. Whole township can utilize this LoRa stuff, for communication. Of course, it's not good for voice. It's you can communicate the data and some of the messages. All right. Then you have the LoRa. This is the specifications. Each region has got its own specifications. European standards has got its own frequency band. Here we have frequency band. It's all modulations technique that one company what is that company? I forgot that. I'll remember that name. They are the one who developed this one. Semtech, I think. Yeah, Semtech is the one who developed the chipsets and all the components to that. So then we have this is the LoRa architecture. All the components are there, and then concentrator and the network server and then applications, and then you have the TCP/IP SSL. This similar communication way what you used to do it for other one, but it has the controlled one. But remember that this is not a completely open source. We have to talk to them to provide you the services that So LoRa, you need to talk to them, get those equipment, and you have to go onto their network. If you want to connect it there. Sigfox is in another cellular one, which is an ultra narrow band technologies, runs on low data transmitting devices. So it requires the less antennas compared to traditional. It is also a cellular, but it is less power, because all the cellular towers have been designed to enlarge it to greater distances, but this one is making for the local area networks. That's fun. And then Sigfox architectures, we have the objects, that's all your devices, then gateway, and then the cloud. They have their own cloud, and then the business applications and IT services there. So then we have all right. So that is about the we talked about the hardware communication from sensor to the microcontroller to the networking equipment, from networking equipment to how do you pass the data to the cloud now, right? Let's very quickly go through that. So we have a HTTP is a very popular one. You have seen that Java or JavaScript, whatever you use it, it's a very powerful. It has been there for last 2 decades, 2 or 2.5 decades. So you send it HTTP request, and then HTTP response comes, and there is a client. So you can have this HTML, JavaScript, Flash processed and run it, right? So HTML5 or JavaScript, you can run it on the client. That's a traditional way of sending the data from your client. So here what is happening is the client is not a desktop. You have a devices here, right? You cannot have this HTTP, such a big bandwidth to send just a binary, 0 or 1, right? Temperature sensor, what it gives you, it tells you 2 wires, right? It tells you voltage, 0 to 5 volt. 5 volt means maximum temperature, 0 is the minimum temperature. You are scaling it up, and you are competing with the higher range of selections, right? Which basically tons of data they're sending it. So that's why we don't need HTTP. Yesterday somebody asked me why MQTT, what is the difference between that? So the thing is, MQTT is designed to transmit low payload, less payload data to the cloud. So this is that HTTP request method. I'm just showing it, but ultimately we are going to use the MQTT for IoT devices. Now it's a hybrid model is coming out, mix and match. So now get method is used to retrieve the information from given server using the given URI, and then we have same as get head the post and put, and then the delete, connect, options, trace. The reason I'm showing is that MQTT is also derived from this whole HTTP protocol, and the approval body is the same, right? IETF is the only, they have made all these changes for, we have blessings from them, and if you don't have blessings, then it's difficult to implement in the market. Response status codes, informal, success, redirection, client, and server, the different description is there. When you're programming it on a HTTP, you will see those aspects to that. All right, now MQTT. So that was about HTTP. Now MQTT is today. We have also CoAP. CoAP still not released officially. It's released, but it's not completely used by the industries. So message MQTT is message queuing telemetry transport created by IBM and Eurotech, and it's actually donated to Eclipse. Then it is very lightweight. It reduces client footprint, and the smallest packet size is reduced to 2 bytes. It's reliable because it has 3 quality of service and patterns to avoid packet loss and disconnections. It's a TCP based. It's not an your UDP, because we have two, right? One is a TCP based, another one is the UDP. This is based on the TCP, and it is asynchronous, and it is optimized for publish and subscribe. When I say publish and subscribe, you're publishing it to the network, you're publishing it to the cloud, and you can subscribe. That means anybody can, say for example, weather data, right? You are publishing it, that weather data, or for example, this COVID-19, the map, where all is happened, you are publishing it, and it is available, subscribing to anybody can see that, right? If you have a mobile app, I can just put my map and then see that how many positive cases are there in my area, right? I think many of you have come across that application, right? So that's nothing but publish and subscribe, right? I'm publishing the data, somebody is publishing it, health department or community, and then you're subscribing it, so everybody can see the data, what is happening there, right? That's the publish and subscribe. Publish the facts, subscribe, everybody can see that. Sometimes you publish, but you limited subscription, you give it to only to community, I mean to your members, right? So that's the, and then lightweight, publish, subscribe, reliable messaging transport protocol. You can get more details on this website, which keeps updating the current status. And then publish, subscribe messaging pattern requires a message broker. Actually, the message broker is required to connect from one platform to another one. The broker is the one responsible for distributing messages to requested clients based on the topic of message. Some people, I think next slide tells you about that. Okay. Somewhere it tells you about that, because I may be interested in getting, or some people may be interested in getting temperature, somebody interested in humidity, somebody is interested in COVID-19 cases, somebody is interested to get the news, what is happening on the lockdown situations, so those messages you can distribute and publish it, yeah. So frame format, this is just when you're sending the data, if you have got the length message, then optional variable, then you have the remaining, and then the message type, you got the field length, and then MQTT fixed, and then this header, 0 to 7, you have byte 1, byte 2, byte 3. So I will not go in details. If you are interested, I have some other things. Okay, so that is about the talk about the this protocols. We use the protocols. So before we go on to the session 2, I can pause here. If you have any question on I2C networking or on the cloud, I'll be happy to answer those questions. Any questions, please? Let me open up the chat window here.
Hello, sir. Good morning.
Yes, sir.
Sir, is there any hands-on on MQTT?
What is the, sir? What is the question, sir? Sorry, there's some disturbance.
Sir, is there any hands-on on MQTT?
Is there any
hands-on?
Oh yeah, MQTT. Yes, we will give you the how to program your MQTT sensor and connect it to the web. We'll give that. Okay. Yeah.
Okay.
I don't know, Bharat. Did you cover up yesterday connecting to any UBI dots or any of the cloud?
No. Today we have a UBI dots MQTT demo.
Yes. Today we are giving that demo. Yeah.
Yeah.
Okay. Thank you, sir.
No problem. Okay, so there is a better, please ask questions through chat, Yeah, there's moderator is saying that pharma industry have lots of processing, so the IoT structure will increase. Yeah, that is true. Yeah, pharma industry have a lot of processing, so IoT structure will increase. That is true. It is very true. Okay, so any other question, please? What is the developer of MQTT? Who is the developer? Okay, this is basically ITTF. They are the one who organization. There's no developer. It's a community, like whoever has created the internet. IETF. They are the one who are behind it, with some companies, of course, blessings. Yeah. IPv4 ADDRESS is used in IoT for multimedia data. Yes, IPv6. It is like a house pipe. You have like I would say it's like you have a gas pipe or a water pipe. Now water pipe is for IPv6. You can use anything that water pipe. If you have IPv4, you use it anything, but you cannot have both IPv4 and IPv6. And you have IPv6 upgrade or IPv4. How to solve with okay issue with our IoT? THQ. Is it ThinkSpeak? I don't know. How to solve the issue with our IoT? THQ. I don't know, sir. THQ, what is that?
Maybe thank you.
Sorry?
It may be thank
Oh,
you.
okay, I'm sorry. Okay. All right, okay. So what is the difference between baud rate and the bandwidth? Yeah. So baud rate is basically, you are transmitting the signal from one to other. The bandwidth is whole system. Suppose you have a baud rate, I say 26 baud is squared 26 kilobits per second. It sends it. But bandwidth is when I'm sending my entire this thing. The bandwidth is a series of your baud rates. Okay. All right. So any other questions, please? If may not sufficient, IPv6 is there. Oh yes, that's a good question. IPv6 may not be sufficient. Yeah, there is research is going on IPv6 extension. Still not released, but I think it can address because we have population of 7.6 billion, right, worldwide. They say it can address 128 bits. I think somewhere I have put that 2 to the power of 128. It can address 3/4 of the populations, not half the populations. There are research going on, how we can extend that 128 bit, floating point, so that you can go on the other direction also. Negative. What is MQTT protocol in the? Okay, we discussed protocol in the IoT. We will use MQTT is nothing but connecting from your devices through networking to the cloud. Like HTTP, is an extension of the HTTP. How secure the IoT device? IoT devices, definitely I cannot say it is secure. It's all depends upon the what kind of application you're using it. If you ask me, mobile devices is an IoT device, how secured? Is not secured. If you are using it for government, yes, it is secured. Okay, how to use MQTT protocols in IoT? We'll demonstrate that. How much area range? So there is no range actually, because as long as you have internet, you are up in the cloud. There's no range for your internet has to be very strong. HTTP is both actually. You come under TCP and ED both. You can configure it. We have a demo. Okay. All right. So let's move on to the this one. Okay. Now then we have the smart city use cases. Before that, Bharat, you want to show that MQTT demo if it is there, because a lot of requests coming up. That will be a good connections to that. You want to show one cloud, external cloud, or the UBA.cloud, how MQTT is connected there. That will be a good connection there. Yeah.
Sorry, I have a complete demo on that. So
Yeah.
once I discussed about the UB.s cloud, and then we have a demo on the how to send the values to UB.s using MQTT. So that I think we can continue.
Okay. Okay. Yeah.
Once your applications are finished, I will continue with that.
Okay. Okay. So let's go on to this NIST smart city, which basically, it's called the National Institute of Standards and Technologies. We do it's called Global City Team Challenge. Anybody can become member for this. NIST is a Department of Commerce in US. For last 3 months, the activity is reduced. Everything is online. You can do it, most of the applications on the, virtually. So, there are several, about 100 plus cities involved in solving this, smart city solutions. So I'm going to walk you through 4 or 5 applications, how we have done it for the global city council. Okay, the first project is for the, okay, by the way, the GCTC is the combination of, of city, then you have the government and university, as well one enterprise company, so we formed it, like Extrans is one of the company who was a part of it, and then university, NIT Warangal, we put it. We wanted to bring Dr. Raju here for one of the project. That did not happen. It was supposed to be in April. Because of this COVID, everything got postponed it here. Everything was approved. It was conferences, we have it 1 or 2 times in a year. So, but hopefully we'll try for the next time. Normally our goal is to invite people here, and they'll be the speaker, and they'll publish the paper along with us, and then they go back and implement it. So it's a combination of city, university, and private company, and national NIST government in US. They provide little funding to people who can really travel, and then provide their solutions to that. So the first project I'm going to talk is Advanced Flood Warning and Environmental Awareness System for the city of Rohnert Park, which is in California. So we have some project we did it. Basically, they want to monitor the floods. They want to keep a monitoring. I mean, flood is a very common problem even in India, right? So they said that can IoT help us to monitor the flood? Then the company Do Mobility, where I'm also co-founder here, we developed a box here which has got several environmental sensors here, which has got the flood, CO2, temperature, humidity, and light sensor. There's one company, they have donated us the satellite. There is no connection, so we just keep it in the forest, and then it detect these parameters and send it to the satellite, and from the satellite it goes to internet. From internet it goes to the university campus, and then it also connect it to the city, because the city is the one who make the decision on that. So basically the problem statement was to monitor the rain, but later on they keep adding the specification. They said, okay, when you're monitoring the rain, why don't we add some temperature, why don't we have the humidity? So then we started adding those sensor to that box, and then we accelerated the program. So this is the project is working now. We demonstrated in GCTC. I'm going to open up one site. Hopefully it is still there. You'll see all those projects there now. This is another one, smart bin waste management design and architecture. So how we can monitor the devices there. So we have basically the idea here is you monitor the level of the trash and then send a signal. I think we have a demo, we have proximity sensor. You can monitor the level of the trash, and then send that signal to the cloud, and then from cloud you send a text message, that will tell you that what the ultrasonic I mean, what the distance of the sensor. I think I have a poster here. See, this is one project we did in the school, which is done in a Cal Poly, which is in south of California, a place called St. Louis. So Obispo. So we put this is a trash and then put some proximity sensor. As you can see, that two of the students, they're putting the proximity sensor to the lid of this trash bin. So whenever the trash is full, it actually measure the level and then send the text message. You know, this is my phone, and they use the car batteries to power, because there's no power here, right? Car batteries to power this microcontroller and the sensor, and then they used to get a text message, and then they monitor the performance, you know, for 48 hours or so. You know? That was just called it as a capstone project, you know. So this is another one, university in Nigeria. We want to do that somehow. Because of this government, we did not implement it, but you know, we did it, smart transportation, smart water, smart you know, actually there is one university in Nigeria, they said, you please make this as a smart campus, you know. And the good thing about that university is all the electricity, water, everything is controlled by that particular university. So but when it went to the government, government did not, you know, I mean, there are a lot of paperwork, there's a lot of other bureaucratic things which we did not really implement that, you know, but we have working prototypes for that, you know. Then one more project we work, Galway smart city in Ireland. In fact, Dr. Martin Sarana is a very friend of mine. He is a researcher. He gave a talk when I was in NIT Warangal some time back. It was in the GAN or E&ICT program. He came online and then he shared his experiences. There we are doing in Galway, that's in UK, near to UK in Ireland. So he is doing is that they're having this energy, technologies, mobility, then healthcare, education. So we are completing some projects. We demonstrated it last year. He got some grants also from the European Commission under 2020. But because of these situations, now everything is stopped. In fact, he was deputed to NIST in Gaithersburg near to Washington, DC. He was supposed to work on this initiative, you know, whatever we create, and he was supposed to be here for 2 years. You know, he's from Galway in Ireland, but now he's gone back because of the situations. You know, government is shut down, and now we'll hopefully we will revert back. You know. So then the smart parking basically is another project based on the global city challenge. So then they have I think block diagram is there. So this is the smart parking with sensors, localization of availability, parking utilizations, and then the tiered pricing parking. You know, the various applications, various parameters we can use it for the smart parking on that. Then you have the smart lighting. Basically, is depending upon the weather conditions, you know, it can display the lights over there. You know, street lights in the smart city embedded for a service to work properly there. So this is the smart lighting. As you can see, there's a pole, and then you connect, some of the, once electronics is there, means you can do it for everything, right? You have the gateway, then you have the, management software, everything is there. Actually, OPEX, the operating expenditure is coming down to that. Let me go to that site and show it to you. This is another one project, which basically a school project again. Smart street light, right? Though there's a light here, a simple microcontroller here, you can control the light intensity or the switching on the light based on this any factors. Sound sensor means any car goes or any human being goes, then light lights here. Then UV sensor is that whenever there is a sunrise, you don't need lights. When sun set, so you need lights, right? So that's why the UV sensor is there. Motion sensor, if any one person goes. This is very good in the rural part of in India, right? So especially we light all the lights which is not required. So instead you can put some kind of an sensor, the what you call that, presence based, whether it's a car is coming or a cart is going or it's daytime, nighttime, if somebody is walking. Of course, we need to have a couple of lights, otherwise we have another security issues, right? Theft issues. But not all the lights, we can light the on based on the requirement. So students have done this project based on this one. It was used the Freescale board, IoT board, but nowadays, yesterday I shown that you can use even that Arduino Wi-Fi board, or Bharat has shown you the Raspberry Pi board. You can use any one of those boards to light on or off. This is an Arduino based board, Freescale. Then smart power grid, so this is in another project we did it for. This is basically in part of this NIT Agartala. They had some incubator, they asked us to do some smart city projects. Basically they invited us to go there and study what requirement, and then there was some incubation funding. Both the government were planning, but somehow that did not work out. So but we did the prototypes for that. So we had a mobile, then the cloud platform. Basically here the idea here is that monitoring the power, how much power or how much voltage and current consumed by each department. So that connects to, that time the Samsung was very popular, Arctic platform. So we connected that, and then there is an through Wi-Fi. We just represented shown a Samsung, Marvel, Intel, or ARM, but you can use any of those processor there, and then connect it to the cloud. And then once it is a cloud, then you can make form factors, right? Mobile, tablet, web, smartwatch, and smart glass. Any of those projects you can connect it there. This is the sense hiking trials. Basically, this is in another project we did for San Luis Obispo. They wanted to keep a track of people walking into the park. Basically, normally, we have this now. It is, we are not able to go out. Otherwise, normally the tendency in US is, of course, everywhere it is increased. Friday or Saturday, in fact, we just go morning 8 miles or 10 miles of hiking, in the park. So what used to happen in San Luis Obispo is that there's one popular park. Everybody started going to that park. Then the city said, no, we have to know how many people are walking, how many people are this thing. So can you put an IR sensor? So we put an IR sensor. It actually triggers how many people are walking into the park, how many people are leaving in the park. So we have this UV sensor, which basically tells you. This UV sensor we put it because we wanted to know whether the person entering anybody after the sunset, because after sunset it is not allowed, they are fined. In fact, now also if you go more than 4 people, 5 people, you will be fined, because it's a law here. You have to have the social distance, keep the social distance. Now this could be a perfect example, right? If somebody is going below, above the 6 feet or 6 feet, right? Yeah, so then it will tell you the city or whoever is that officer, right, that people are not following that rules. In fact, one of the project, it reminds me in universities that they just done a fun project. There's a badge, they put them ultrasonic sensor 6 feet, ultrasonic sensor, they adjust the distance. If somebody come closer to less than 6 feet, then it will give some buzzer or give some light. Of course, we can use it only in some limited system. If you use it in a crowded place, then all the buzzers will start, right? People are going walking on the places. But that's a good innovative, right? They put approximate sensor, and then if anybody coming less than 6 feet, then it will start giving a buzzer, or some LED. So this is a similar concept. Only thing is, in this case, they used the GSM here. There's a company called uBlocks. They use the LTE because there's no, even in the earlier one, you saw the trash can. We use the UBI block. We don't have the Wi-Fi. We don't have the Bluetooth. So it's a park, right? So we use the GSM 3G. That time was the 3G GSM, and then we use the Open IoT, the cloud, so that you can. Open IoT is from that Ireland, so that they have transmitted to the OpenIoT. OpenIoT provided as a free services. Anybody want to do any research project, I highly recommend you use the OpenIoT. So this is that park, as one of the student holding the proximity sensor, ultrasonic sensor, and then the board, the temporary scale board. So this is that park. You see Bishop Peak is a very popular park in San Luis Obispo. We use that to monitor number of people entering and number of people leaving the park. This is some test result. Only 3 people were there. Is a peak of the summer. Me and another professor and one more student actually. Okay, now comes to the irrigations. How IoT can enable for the irrigation control. One of the project we used is, this is what diagram I want to show. So basically it measure the moisture of the soil and then send the some kind of a triggering signal to the water pump, whether water is needed or water is not needed, So it's basically a IoT enabled agriculture system, So you can pump in the water depending upon the moisture, We realized during this project that each plant has got its own moisture, I mean, we didn't know that. We are not an agriculture specialist, but we went to an agriculture or we did some research. That study shows that each soil has got some kind of an what you call that limitations, that if the soil level goes certain level, that time the water is required, So as you can see, there is a a relay which actually operates or de-operates, depending upon the moisture level here. The moisture sensor is here. It goes there and it connects this to the output relay there. This is that integration of the circuit. I mean, we just monitor, student have monitored with their laptop there. This is the test results on the web services, how we can do it on the test result. They've done that. So that's about the GCTC projects. Now let me open up the GCTC if it is there still. So you can open up the GCTC, okay. Global City Team Challenge, Global City Team Challenge. So this is the site, which as you can see here, this is from the National Institute of Standards and Technologies. You have got a different super cluster there, actually super cluster. So we have hope I'm audible, right?
Yes, sir.
Yeah? You can see my screen, right?
Yes.
So this is just a website. I mean, you can see those, I'm part of education cluster. Then let's see. This is education super cluster. No, our job is to go and teach the smart city, smart what you call this smart some of the cities and the universities, to combine this IoT course there. So we have a super cluster. So these are super cluster, and then we have the under that we got several of them. See, for example, you go to the education super clusters. So in this one you go there and you can education super cluster here. So action clusters are, you can just see here, smart neighborhood, and these are the different projects here, So and so these are the different projects. You'll see that. So this is the one actually we presented it. civic engagement and IoT enabled smart city workshop. You will see here. So this one is IoT enabled smart city workshop. We provide the workshop based on the hardware board, whatever we created. It's based on the multiple things. So this is the IoT enabled smart city workshop. So we provide a workshop here. Okay, so in this we have multiple people involved in that, right? So yeah, so you can go more details, you'll find out all the projects aspects on that, Yeah. So but it's very interesting, you can go to GCTC. Anybody wants to be part of smart city, you're more than welcome. Contact me or Bharat or Dr. Raju. We'll be able to help you, walk you through that. But now it is a little bit of slowdown. Everything is online. There's no travel, nothing. So we'll see. Hopefully it will open up very soon. So, but it's a very encouraging practice. So we have several team working on that. Okay. So with that, I will stop here or ask any questions you have. Then we can move on to the next one, right? Hope I'm able to see that. So let me see here. Here we are. So yeah, Bharat, you want to take the demo?
Yeah, hello.
Yeah, Bharat. Yeah.
Yeah, sir. Let me give 1 minute. So
I will open up the forum. Any questions they have? Let me see. I'm just trying to open up my screen here. Okay, I'm at the screen. Okay. So any questions they have, I can always answer to any of your things on the 3 chapters we covered up, right? The protocols, then protocols from hardware to the microcontroller networking to the cloud, and also the smart city projects. How we have implemented. I'll be happy to answer any questions before we move on to the next session. We are running a little bit out of time, but still, we can take a few questions here. Yeah, please type your questions here. Okay, that's good. Thank you for the compliments. That's a good project. Thank you. Then we have one. Yeah, I mean, somebody saying that it's going to create unemployment. I don't think unemployment. It's actually generate a lot of IT jobs, right? We need people to maintain that, right? We are talking about the IT here. Smart bin project for the battery power, can we place? So yes, that's a good question. Actually, yes, we can put the solar panels. Thank you. So I think there's a participant called NIT IoT 289. That's very good questions. So we can replace.
Sir, hello. Hello.
Yes, please.
Hello.
Yes, please.
Sir, I have been asked the question, sir. That is, I have seen all the projects, sir, what you have shown till now. My doubt is that regarding the solar panels, for the battery purpose, can we place any solar panels so that it will be better, sir?
That's right. Our next project is to only to use the solar panel. That's right. Yes.
I have seen your irrigation project, sir. There I have seen battery for the power.
Ah,
Battery for the power. I have seen in the picture, sir.
battery. Yes, yes. I have seen
I have
for
seen the
the.
battery in the picture,
Yes,
sir.
yes,
Irrigation project.
yes, yes. Correct.
So,
We have.
and I've also seen the smart bins where you have placed near the bins. You are placing the panels, so sir. So I have it. I got an idea that we can place the solar panels, no, so that
Yes,
power consumption will be good.
that's true. I mean, we had only 3 months of project. We did not had that much of time to really get that, but that's good. They just managed to get a car battery and they tested. But you are right
Ah,
for the future. In fact, you are right. One of the project we took it to the one of the Austin smart city. There we found a smart the solar panel there. No? Yeah,
okay.
that's right. Thank you.
Thank you, sir.
Thank you. Okay. Any other question? Let's see here. A lot of
Yes.
what is HTTP and what port is used. A lot of this stuff. HTTP and all we are going to cover up again. No? Yeah, how we can use IoT in this COVID-19 to reduce the. Actually, we are creating another seminar. I think I can cover up that also with when Dr. Raju conducts. No, we are doing some projects on the COVID-19. I will show some demo. Still not ready. We have some demo. Maybe next one when Dr. Raju conduct. No, I'll be able to share those programs. Yeah, health only we are trying to do that. Health project we have several of them. Health I can show some projects, but currently I don't have the setup. I have only the theory part. Post COVID is very important for all of us. Yes, that's right. Basically, see COVID-19. There are several projects we can do. One is monitoring the temperature, monitoring the presence. Say for example, I'll give you an example of NIT Warangal. Or any of your campus. If the security person at the gate has got some kind of an instrument that he or she in the security checks the temperature of the person walking into the campus and send that data to the health department up to the whoever is the health managing in the university, saying that okay, this person is entering now that he has got his temperature, what we should be doing it. That's a centralized data, they can connect it, right? Otherwise what happened is now they check it, what they will do the next. That's one. The other one I saw in the airport, somebody was shared with me, is that you check the temperature and then only you allow that person to board the flight. It will go there and it will print the boarding pass only if that person has got a less temperature. If it is more temperature, automatically the robotics won't allow him to issue any boarding pass. That's a big project, right? If my voice is not audible, it's saying Bharat, Dr. Raju, is my voice is audible?
Yes, sir.
It is maybe the network problem of them.
Okay. So yeah, sorry, I think probably you have to set up that network. The another one is the banking fraud detection analysis. How for support of IoT? Yeah, we can do the banking fraud detection analysis. How for support in IoT? We can do the banking fraud, but we are talking about the COVID-19. No? So banking fraud, we can get all the database at one place. If somebody is corrupting or misusing that, then immediately they can send a message to the police or 911. They can try to grab him. I mean, try to catch him. So banking, then okay, then what else we have? Continuous monitoring for continuous monitoring for vitals is there, and more interested the COVID-19 also. One is the temperature monitoring, and second one is you get it's basically mix of IoT and artificial intelligence. Whenever you walk into some area, you get some kind of an indications, right? In that locations, how many are COVID positive patients are there, whether it is safe to walk, is there any nearby hospital which has got the COVID this one. So all those aspects, we can monitor using the IoT device. So you have some weird IoT devices, and it will tell you that this is, oh, COVID-19 patient who got discharged again turned positive. Can we use IoT along with machine learning algorithm? Yeah, we can use that actually. Whoever has got the positive is already there in the database. You can use that another tool to these things. And home-based monitoring, you can use it. I think as we speak, I'm doing a lot of research. We can do several things on that. Yeah. For working parents, monitoring kids not possible. Is there any project? Working parents monitoring kids. Now all the parents are at home, no? So they should be able to monitor the kids. At least they're able to spend some time. Misused of use of tell briefly, sir. Misused of use in fraud. Okay, working parent monitoring kids not possible. Yeah, that's true. Misused of use. Yeah, I know. It's misuse is there. You can always monitor that what is existing presently, and then we can communicate to the fraud department or police department. Yeah, that's right. Yeah. All right. So I'm here for some more time. We'll take questions, but I think Dr. Raju will continue now, or how is that?
Sir,
We'll continue, Pan? Shall we continue?
yes, sir. Yes, yes.
Okay. Yeah, Bharat, over to you. Can you show that cloud?
Yeah. And I'm requesting
cloud now, how you are going to do.
Hello.
Yeah, I'm going to mute.
Hello.
Yeah, Bharat, you go ahead.
Yeah, actually, I don't have the presenter mode. So
Mr. Chandra,
I request Prasad. So Prasad, can you give the presenter mode permission for me? Yes, thank you. I got it. Okay. So now, are you able to see my screen? Yes. Okay. Right.
Yes.
Okay. Right. So let me go through that before break. Let me go through the introduction to the Raspberry Pi, so that we can do one or two sensor integrations with the Raspberry Pi, and then after that we'll see the cloud introduction. I will show how to create the account in the UBI.s cloud, and I will show how to send the values to the cloud using HTTP and as well as MQTT. So both protocols I will show how to use the HTTP and how to use the MQTT protocols to send the values to the cloud. So this is the complete agenda for today. So let me start with some introduction to the Raspberry Pi, and after that we'll go slowly into the sensors. So I hope most of you people know about the Raspberry Pi. How many of you worked on the Raspberry Pi? Can you ping it on the chat box? Is anyone have experience in Raspberry Pi? Okay, few people. Okay. So most of the NITs are saying yes. Okay, right. Okay, right. Anyhow, before going to that, let me introduce few things about the Raspberry Pi. So this is the picture that you are seeing here, the Raspberry Pi. So this Raspberry Pi is a mainly it is a OS based, operating system based. So that back side of here you can see this back side of Raspberry Pi, we are having one SD card. So that in the SD card we have to load the operating system here. So that this operating system is a Linux flavored operating system. So most probably we'll use the Raspbian operating system for the beginners. So it is a very easy to operate. And here we are using a SD card, and 4 GB is the minimum SD card that we should have to use for Raspberry Pi 3. But 8 GB is the recommended SD card. 8 GB is the recommended, but 4 GB we have to have minimum size of the SD card should be 4 GB. And you can have a look here so that we can discuss some points over this. So you have all the 4 USB ports available here. I think you are able to see my screen, my cursor. Yes,
sir.
Okay. So here we are having 4 USB ports. So these USB ports are used to connect the external keyboard, USB keyboard and USB mouse, or otherwise you can connect any external memory like pen drives or whatever it is, or otherwise you can connect any external cameras, USB cameras you can connect, or otherwise you can connect any USB related devices you can able to connect over this particular thing. So all these 4 are USB 2.0. So I think you know we'll discuss about that USB 2.0 and 3.0. So we have 2 different versions of USBs available, and this is the Ethernet cable. So this Ethernet cable is used to connect the Raspberry Pi to the internet connection. So that here this Ethernet is a 10 by 100, so 10 Mbps or 100 Mbps speed. It will support both 10 Mbps to 100 Mbps speed. This particular Ethernet will support. Okay, more than that it will not support more than 100 Mbps speed. So this is used to internet connections. So you can easily connect your Ethernet cable from your modem to this Raspberry Pi. And we have an audio and video jack available over here. So this audio and video jack, we can connect our audio inputs like earphones or whatever it is, but it is an audio out jack. You have to remember here is it is an audio out jack. So whatever the sound which is playing inside the Raspberry Pi, we can able to listen to that particular sound. But we are not giving any inputs to the Raspberry Pi. Raspberry Pi, there is no audio in available in the Raspberry Pi directly. Directly, there is no audio in available in the Raspberry Pi. It is only audio out. So we can able to listen some values from the Raspberry Pi. And we have one camera slot available here over the Raspberry Pi. We have some CSI camera. We have some CSI camera port is available. This camera port is we can connect some Pi camera available over market. So we can connect a Pi camera over here so that we can do some image processing applications using some OpenCV OpenCV packages. So we have some package called OpenCV. Using that package, we can do some image processing applications by connecting the camera over here. So this is one. And next we have some HDMI. So as you know, we have to provide, whenever it is operating system, means we should have to provide some monitor to see the file structure, to see what is happening inside the Raspberry Pi and all. So to see all those things, we have to provide a monitor. So this HDMI port is used to connect the HDMI monitors to the Raspberry Pi. So generally will RS232 monitors available in the institutions, generally that RS-232 we can use some converter from RS-232 HDMI converter, and using that we can connect a RS-232 monitor also over here. So this is generally used to connect the monitor. And here we have a micro USB cable to power the Raspberry Pi. So generally we can use the 1 ampere 5 volt 1 ampere 5 volt 1 ampere adapters to operate with your Raspberry Pi. So here again it is most of your mobile chargers. We can use that mobile chargers to connect to this Raspberry Pi. It is same like your mobile charger, like it is a USB-B connection, the Type B connection. Okay, so generally this type of connection is called Type B connection. Okay, so next we have a DSI display port. See here, same like your camera port, we have another port like called as DSI. See here it is CSI means camera serial interface. What do you mean expansion of CSI is camera serial interface. Similarly here we have a DSI, display serial interface. Display serial interface. So in this display serial interface we can connect external displays available, small displays. Instead of connecting our regular monitor, if you connect any other external display, we can connect the external displays over here. So other than this, all the components, we have a GPIO available over here. So this GPIO we can able to connect all the sensors over here. So we'll discuss about this GPIO later. So these are the features of a Raspberry Pi. So let me discuss. How many of you know that Raspberry Pi is going to be operated with SoC called BCM2837? So this SoC is a nothing but it's a processor along with some other combinations. So generally, what is the processor used in the Raspberry Pi is quad core, 4 times of ARM Cortex A53. ARM Cortex A53 is the processor. It's a 4 times means quad core. It's a quad core ARM Cortex A53 with a operating frequency of 1.2 gigahertz. So along with this CPU, we have internally math processor available, and we have internally along with audio processor available. So all this along with this processor, CPU plus this audio processor, math processor, everything will come considered into one chip called SoC. So this SoC is going to be it's a combination of processor plus extra processing units. So which are all are going to be combined into a single unit and call it as a SoC, system on chip. Okay, so this is our SoC used in the Raspberry Pi 3 is a BCM2837, and what is the operating frequency here is 1.2 gigahertz. And yesterday we spoke about that Raspberry Pi will support some GPU, so that it will support some video core 4 GPU. So this video core 4 is one of the popular GPU. So that is going to be used in this particular Raspberry Pi for image processing kind of operations. Okay. And next we have a 1 GB RAM. 1 GB RAM. So as you know, as we have the size of the RAM is more, so we can execute more number of applications in a good number of with good speed. So whenever RAM size is more, we can handle more number of applications at a time. So application speed, the processing speed will increase, programming speed will increase as you are increasing the RAM size. So mainly this RAM size is useful whenever you are doing the operations with image processing and all these things. So in that particular time, we will make use of this RAM size. So networking, you are already seeing that Ethernet, it will support 10 by 100 Ethernet connection, and as well as it will support the 2.4 gigahertz wireless connection. So it is a Wi-Fi. So what is that? Here it is. This is your Wi-Fi. So Raspberry Pi will support the internal Wi-Fi with a frequency of 2.4 gigahertz. Mainly in India, will use the two frequencies for Wi-Fi. One is 2.4 gigahertz. One is 5 gigahertz. So this Raspberry Pi 3 will support only 2.4 gigahertz Wi-Fi. And Bluetooth, we have a Bluetooth 4.1, and as also it will support the low energy BLE, Bluetooth low energy, and as well as classic Bluetooth. Both type of Bluetooths will be supported by the Raspberry Pi. It will support classic Bluetooth and as well as low energy Bluetooth, BLE. We can call it, generally call it as a BLE. And the storage is provided by the micro SD card. So this micro SD card is having 8 GB of memory. And already you know that it is having a 40-pin header, which is going to be populated. And these are the ports which are available. Already we discussed CSI, DSI, 4 USB ports, and 3.5 mm analog audio video jack, and HDMI. So these are the few features regarding the Raspberry Pi. But now most of the people are using Raspberry Pi 4, so they are slowly shifting. Of course, we are also planning to update the Raspberry Pi 3 to Raspberry Pi 4. So what are the general and the extra features that Raspberry Pi 4 is having? One important feature here is the processor speed is increased from 1.2 GHz. It is increased to 1.5 GHz. That is the first one. So let me open that. So here you can see that processor speed is going to be increased to 1.5 GHz. So there is a one thing that it. And what is the Ethernet? Ethernet, earlier it is 10 by 100, but now it is Giga Ethernet. Giga Ethernet means the Ethernet speed is changed from megabits per second to gigabits per second. It is the Ethernet speed is drastically increased. Okay, and also it will support the Wi-Fi of 2.4 GHz, and also it will support the Wi-Fi frequency of 5 GHz. It supports both the frequencies. It supports both the frequencies 2.4 GHz and as well as 5.4 GHz. And Bluetooth is increased to 4.2. So Bluetooth speed and accuracy will be increased over here. And it is having USB 2.0, 2 ports of USB 2.0 and 2 ports of USB 3.0. So what is the difference here? What is the specialty of USB 2.0 is it will support only 60 Mbps speed. So whenever 60 Mbps speed supported by the USB 2.0, whereas in the USB 3.0 will support 640 Mbps. So drastically increased. The speed is increased drastically. So whenever you see any USB ports, can you tell how to recognize whether it is a USB 2.0 or 3.0 port? Can anyone have any idea how to recognize that particular USB is a 2.0 or 3.0? By seeing itself, by just look, we can able to, yes, it is whenever we have a blue bottom. So whenever we have a blue color in the USB, then it is 2.0, and whenever we have a black one, so it is a 2.0. So whenever it is blue, it is a 3.0. And but nowadays USB 3.1 also comes into picture. So that USB 3.1 is generally supports up to 1.2 GHz, and it will having a color of red. Okay, so generally it will have a red color. So by seeing that red color, we can understand that it is a USB 3.1, and also the speed of that particular is not gigahertz, it is Gbps, gigabits per second. So gigabytes per second. So this is the different USB ports that are going to be available. And also what is the specialty of processor 4? It is having 2 HDMI ports per display. So here 2 displays are available. Sorry, 2 display ports are available. HDMI display ports will available 2 display ports, and here with high resolution, 4K resolution. 4K resolution is available in the Raspberry Pi 4. You might have seen that yesterday. You have seen the Raspberry Pi screen. It is a little bit duller because the display, that particular HDMI port, which supports a slow, it's a low resolution. So that's why it looks like a little bit dull. But whenever compared to this HDMI ports in the Raspberry Pi 4, there supports the high resolution, so that your picture clarity, that whatever the GUI is going to be very high end. Okay, so this is about resolution, USB ports, Wi-Fi, Giga Ethernet, and processor speed, and remaining all are same. So even Raspberry Pi 4 also is having and these things, and what all the ports are same: CSI port, DSI port, all the 40 pin GPIO, everything is same. So we can easily replace the people who are working with the Raspberry Pi 3. We can easily replace the Raspberry Pi 3 with the Raspberry Pi 4 without any disturbance. Only thing is that here the HDMI port is not available. That earlier HDMI port is different, and here this HDMI port is little different. It is a this HDMI port is having a mini HDMI port. It's not okay. So here you can see there's a mini HDMI ports available over here. Okay, so this is something about Raspberry Pi 4. So other than this, sorry, I forgot one of the specialty of this Raspberry Pi 4 is having a multiple RAMs. It supports 1 GB of RAM, it supports 2 GB of RAM, and it also supports 4 GB of RAM. So 3 flavors of RAM is available. Whenever you want to buy Raspberry Pi 4, they will ask whether you want 1 GB RAM or 2 GB RAM or 4 GB RAM. So that according to your requirement, this particular chip will be changed. So this is a 1 GB or 2 GB or 4 GB. So according to your requirement, they will replace the chip with the different sizes of RAM. Okay. So this is some information about the Raspberry Pi 4. So, but presently we have only Raspberry Pi 3 with us. So we can able to go through this Raspberry Pi 3 for present. Okay. So let me see what are the things required, minimum things required. So one is Raspberry Pi, that is, and 16 GB. So we are recommending 16 GB micro SD cards. I'm sorry. So we are recommending 16 GB micro SD cards, and here these micro SD cards should be, and here these micro SD cards should be class 10. So you can otherwise. So whenever you are buying the micro SD cards, please ask them that it is a class 10 SD card. So because in the general mobile will use a low speed SD cards will use, but whenever we want to go for Raspberry Pi, whenever you want to install the OS, so we have to use the class 10 SD card. And what is the OS that I'm using here is a Raspbian Stretch. So this is a OS that I'm using here. It is from again Noobs package. It is from again a Noobs package. Okay, so this is the OS name and this is the package name. So again, this is from Noobs package. I'm using a Raspbian Stretch. Okay, so this is about Raspberry Pi. So is there any doubts regarding Raspberry Pi? Machine learning algorithm. So what do you mean by machine learning algorithm? Okay, right, fine, okay, right. Finally, we'll go, before going to the program, we'll see the pin diagram of Raspberry Pi here, because this is very important for us to connect the sensors to this particular Raspberry Pi. So how much it's cost? The cost is around 3,000 for Raspberry Pi 3. It's around 5,000 per Raspberry Pi 4. Okay. So anyhow, if you observe this pin diagram, we have a left side here. It is started with pin number 1, and right side it is pin number 2. It's an alternative pin numbers. Pin number 1, pin number 2, pin number 2, pin number 3, pin number 4, 5, 6, 7, 8. So like that, there is some alternative pin numbers available over here. It's not like a direct sequence pin numbers, it's alternative pin numbers. So whenever if you are observe the Raspberry Pi opposite to your USB ports, the top side left inside the Raspberry Pi, it is a pin number 1, pin number 2. Because I know people who are working with the Raspberry Pi in the starting, they will be confused with the selection of pin numbers. So that's why I'm typically I'm saying like this. So pin number 1, pin number 2, like this. And also this Raspberry Pi pin numbers are divided into 2 groups. If you observe this, we have 1, 2, 3, 4. Some numbers are given to the pin numbers, and also beside the pin number 3, we have a GPIO number 2. Beside the pin number 5, we have a GPIO number 3. So like that, all GPIO pins. So we can represent one pin in a 2 different ways. We can represent in a physical number, pin number 3, or we can represent in a GPIO number, GPIO 2. So the same pin can be addressed either using a physical number or either using a GPIO number. So that is a main thing that you have to remember here. The Raspberry Pi pin numbers are going to be addressed in 2 different ways. One is physical numbering and the second one is GPIO numbering. So other than this, you can observe this, there are some I2C pins available. Morning you have seen hardware protocol I2C. So I2C is having a SDA and SCL, data pin and clock pin. So whenever you want to connect any I2C related sensors, you have to use this SDA and SCL connection. And similarly, we have here MOSI, MISO, and clock. So these are SPI pins. So serial peripheral interface. So to connect SPI pins, we required these pins. This master out, slave in, means master is sending the information, slave is taking the information. MOSI is nothing but master out, slave in. Similarly, MISO, master in, slave out. Master is taking the data and slave is sending the information. And this is the clock. This is the clock which is going to be the entire operation is going to be driven by the serial clock. And similarly, we have 2 enable pins over here. Either we can use the 24th pin as a enable pin, chip select pin. So you have discussed already. So chip select pin is used to enable particular SPI device. So we can connect multiple SPI devices, and if you want to communicate with a particular SPI device, you have to enable that chip select pin. So whenever you enable this chip select pin, that particular SPI sensor will be activated and it will do some communication with the Raspberry Pi. Okay. So other than this, if you are seeing all these GPIO pins, there are totally 26 GPIO pins available. Okay. So let me open that. Okay, right. So okay, right. There are totally 26 GPIO pins available over here. So if time permits, we'll start the demo right now. So shall we go through the demo?
Yeah, Dr. Raju, what is the schedule now? It's 12 o'clock there. What is it? Almost 12 o'clock, right? Yeah. Hello.
Yeah. So after the break,
So you want to take a break?
how one can know if RPI corrupted? So you can we'll take some questions. How here it is RPI. How one can know RPI is corrupted? So we can know actually whenever your Raspberry Pi is in a good condition. Whenever you power on your Raspberry Pi, it will boot the OS, whenever while booting the OS, it will give a green color LEDs blinking continuously. So whenever a green color LED is blinking continuously means it is booting the OS and the Raspberry Pi is in good condition. So whenever that is not in good condition, you will get some red color LED over there. Okay, Mahbub Hussain. Okay, is it okay? Okay, right. And sir, is there any possibility to simulate the code in RPI before downloading it in the hardware? See, RPI itself is working on the operating system, so it's not kind of thing that because RPI operating system means we can execute any Python program. But whenever you want to test with any sensor, definitely you have to connect to the pins of the Raspberry Pi. There is no simulation available for the Raspberry Pi. Till now, there is no simulation available for the Raspberry Pi. Does it support Windows? Yes, it will support the Windows operating system. It is there is a OS specially available for Raspberry Pi. That is Windows IoT 10, Windows 10 IoT operating system. Windows 10 IoT operating system. And which type of OS used for RPA3? It's a Linux flavored. Earlier I discussed that. It's a Linux flavored. It's a ARM32. Generally, in the Raspberry Pi 3, we'll use the ARM 32-bit ARM processor. Sorry, OS is Raspbian. We'll use the Raspbian Stretch or Raspbian Classic. Different Raspbian flavors are available. We'll use that particular OS in the Raspberry Pi. There is an official site available, raspberrypi.org. So if you go to raspberrypi.org, there are Raspbian Stretch available, Raspbian Buster available. So like that, so many Raspberry Pi OS is available. You can download any of the one OS and you can write the OS into the SD card. Can I give the audio input through any USB? Yes, we can connect micro USB. Sorry, a microphone through USB connection. You can connect because there are some things are available. So through that we can easily connect. So let me give. Yeah, it is possible to connect the microphone through USB. Is any PWM pins available? Yes, there are 2 PWM pins available in the Raspberry Pi. So you can operate the PWM operations also through Raspberry Pi. Can we reserved pins? How do you remember reserved pins? So because already there are 2 pins already available, 27 and 28 are reserved pins. So we can't use those 2 pins for any operation. Yes, Raspberry Pi is having only digital pins. There are no analog pins available. So if you want to connect through analog pins, you should have to use the something called MCP3008, some ADC chip. Any ADC chip you can use. Most probably, I'm using MCP3008 in my IoT development kit. I used MCP3008 ADC. For sensors, means you are saying that you want to reserve any pins for the sensors, Vijay. So do you mean that you want to reserve any pins for sensors? Why other conventional ADCs can be used with can't be used with? It's not like can't be used. Here this is the minimum ADC that is going to be used, a 10-bit ADC operations here. So there are so many other ADC chips are available, 16-bit ADC pin, chips are available, and yeah, right now up to 16-bit ADC pins are available. So those ADC chips you can use. There is no rule, there is no particular that only this particular ADC chip has to be used. There are other ADC chips available, more resolution. So as you know that ADC means as the number of bits increased, the resolution of the sensor increased so that we can read very accurate values from the sensor. So in that case, if you want to make use of your sensor very accurately without any compromise, then you have to go for the 16-bit ADCs. Okay. Yeah. Any other questions?
All right. So, so Dr. Raju, we will take a break and then we continue that, right?
Sure. Sure, I will explain one digital sensor and one analog sensor for sure. Okay.
Hello.
Yeah, hello.
Yes, Mr. Chandra, can we, what is the schedule now? We'll continue?
No, we'll take break, sir, now.
Okay.
We'll take break. Okay.
Yeah, sharply 1 o'clock we'll meet once again.
Once again, we'll make it 1 o'clock. So I may be coming for a few minutes and then I will log off. But yeah, I'll join just after the lunch.
Okay,
And
sir.
take any logistic questions and then I will take off. Okay.
Okay, sir. Yeah, all the participants are requested to join with your ID only. Some people are not joining with your ID. It's very difficult for us to take attendance. So better please log in with your ID only. Thank you.
Yeah. Thank you. Thank you, Mr. Chandra. Thank you, Dr. Raju. We'll see you back. Thank you.
So thank you. I will be back.
Okay.